All right. So, good morning, good afternoon, good evening, wherever you're joining us from. Either you're joining us, welcome everyone. All right. So, we already have our instructor here, Paddy Adala. I don't know if I got that. I think I got that right. He's based in England, United
Yes.
Kingdom, and he's a cloud expert. I'll call him the cloud expert, and he's going to be taking us on AWS networking. Yes, so welcome, Paddy. Welcome once again. So please, for those of us here, we are not really a lot. Please do well to drop a message on our Discord room so we'll have more people joining us. Yeah. So thank you so much, Paddy. You can start.
Sure. So please confirm that you can hear me.
Yes, I can hear you.
All right. Thank you for having me here. It's a pleasure to be here. And a point of correction, I'm currently based in Nairobi, Kenya, and that's where I'm doing my presentation from. Nonetheless, on to the topic for today, AWS networking. So everyone around the world is talking about cloud, and businesses would like to consume cloud services and improve services to their customers or improve the quality of delivery to their clients. As we explore moving to the cloud, then we need to make sure that we cross all our T's and dot all our I's for these engagements. And one of the core pillars that comes into play is ensuring that your AWS environment is properly networked and properly secured. So I will start with the networking aspect of AWS. So the agenda then for networking is to first introduce you to the global infrastructure that AWS has. We then go in and explore Amazon Virtual Private Cloud, which is the container that you put your resources into. We will look a little bit into how you can secure your virtual private cloud, and then we will look at how you can peer and form connections with the services that you have deployed on AWS. As you can see from the map here, AWS is globally available, and the pins you can see on the map showcase the regions that AWS has deployed all over the world. So a region is a group of availability zones, and an availability zone then encompasses different one or two data centers that are geographically away from each other. So specifically here in Africa, we enjoy a region in South Africa where clients can deploy their workloads. You have the option of deploying your workloads or your resources globally. And depending on where your clients are situated, you can use services such as uh, can bring services closer to your clients using the geo services that or the geo features that AWS boasts of. As I mentioned, a region has an availability zone. So a region is a geographically separated cluster of availability zones. Within a region, we have availability zones, and inside availability zones, we have data centers. So availability zones consist of one or more discrete data centers, and these have redundant power, networking, and connectivity. So if you go to your AWS console as you deploy resources, then you are given the option of choosing the availability zone that you want to run from. So this is how these resources are set up. What then, or what is a networking container in AWS Cloud? We call it a virtual private cloud. So within a region, as you deploy your resources, as I mentioned earlier, you're given the choice of selecting your availability zone. Deploying your resources, for example, in one availability zone gives you an uptime of 99.5 from the SLA. What this means is for 99.5% of the year, you are assured, or AWS assures you, that your services will be up. However, for up to 5 days in a year, there might be downtime for your resource. If you deploy this within two availability zones, this gives you what we call high availability. High availability increases the service uptime of the services that you deploy, and you now get to enjoy 99.95 or 99.99 as you increase the number of availability zones that you deploy your resources to. Because we mentioned that the virtual private cloud is a huge container where you put your resources, then you need to design a networking structure for how your EC2 instances will communicate with each other and how they will communicate to the internet or to other resources outside your cloud environment. As you can see, the first address, if you're coming from a networking perspective, is always reserved for the network address. In AWS, the second address, the .1, is reserved for the router. .2 and .3 are reserved for use within the system. And the last IP within any subnet is always reserved for network broadcast. So it is important to take this into consideration as you assign IP addresses to your resources within your subnet. There's also elastic IPs, and elastic IPs are public IP addresses that AWS provides that can be attached to your instances for communication with or to the internet. Now, you have set up your resources inside your VPC and inside your availability zone, but you need them to communicate with each other. So take an example of the Frankfurt region. You have deployed resources in availability zone 1 and availability zone 2. You would need some type of networking mechanism to enable these resources to communicate, because the principle of least privilege also applies to how your networking is done. So by default, there is no communication between your resources. And you, as the systems administrator or the cloud operator, has to put mechanisms in place to have reachability between your resources. And this is controlled by route tables. So an example of a route table is shown there, where we have allowed the network 10.0 to reach a different network or to reach 10.1. So your target, if it is local, it means that the resources within these subnets will be able to communicate with each other within your VPC across the availability zones. Therefore, it is very important to take into note your network design as you deploy your services in the cloud. Now that we have deployed our resources within the availability zones and they're up, how do we take care of securing our networks? Because if you're familiar with the TCP IP OSI layer, or rather the OSI layer, then we have different levels of interconnecting systems. And at layer 3 comes the network layer. So to configure security within the network for your AWS environment, we have, first of all, you enable communication using the route tables. Second comes the network access control list. So network access control list control or give permission to or not to what traffic can come into your subnet. And these are stateless resources, which means that you have to explicitly define what is allowed to come in and what goes out of your subnet. Resources that you deploy are deployed or are put up inside security groups. And security groups determine what traffic under which protocols can get to your instance or not. The difference between network access control lists and security groups is that security groups are stateful. By stateful, what that means is you only have to configure them in one direction, and the return traffic will be allowed by default. What this goes a long way to achieve is to ensure that we control who can access our resources or instances within our subnets. So, as I mentioned, security groups are stateful. However, they have a default deny. So, sometimes you have deployed your resource in a subnet and you're wondering why you cannot reach it, either by ping on the ICMP protocol or through SSH. You need to look into the security group that is attached to this instance and ensure that you explicitly allow whichever protocol or traffic you want to reach it. Otherwise, it has a default deny and no rules are defined to allow traffic to reach or to leave your instance. Network access control lists, on the other hand, also being stateless, have to be defined. And for network access control lists, you have to define both inbound rules and outbound rules. Because if you only configure an inbound rule, then traffic won't be allowed to get out. We go to the next phase. So your resources have been deployed within the subnet inside an availability zone. However, you need internet for this. Say you are running a web server in an availability zone. To provide internet for your resources, we bring into play the internet gateway. So the internet gateway is the service or is the tool that AWS has to allow internet or to allow internet reachability to your resources. And how do you do this? You simply create an internet gateway and attach it to the VPC. Once you attach the internet gateway to the VPC, then you edit your route table. Remember, it is the route table that determines the flow of traffic. Therefore, once you create your internet gateway and the internet gateway attachment to the VPC, then you define flow of traffic into and out of that subnet. Despite or once you have your resources in subnets, we have public subnets and we have private subnets. Public subnets are resources that are reachable from the internet. Therefore, if you have a web server and it sits in a public subnet, it would have a public IP that users can ping or reach from the internet. If this web server has a database, it will be recommended that you deploy it in a private subnet. So resources in a private subnet or resources in private subnets do not have direct internet access from the internet. Therefore, they cannot be reached from the internet. However, these resources occasionally need to get updates. So how do you update a resource that doesn't have direct internet connection? We use NAT gateways. NAT is network address translation. So you deploy your NAT gateway in the public subnet, and when you want to get an update, then the connection is initiated from your instance that sits in the private subnet. Once the traffic gets to the NAT gateway, then NATing happens, that is network address translation, and the request is sent to the internet. Because the connection is stateful, then you can receive a response. Remember that for traffic and we have deployed we installed between or inside multiple VPCs. How do we connect them? Do you simply create a route? Because I mentioned that route tables govern traffic flow between our resources. Or how would you go about it? One is off the head or off head or without experience. One would think of it that you would simply peer or form a peering connection between your VPCs. It is possible to do this. However, the number of peering connections, because these would form a mesh, increases exponentially as the number of VPCs that you have deployed increase. And this ends up bringing a networking nightmare. So what is the problem with connecting each VPC with each other in a mesh topology from a networking perspective? The complexity. Imagine if you have 100 VPCs, then you would have 4950 connections, peering connections. However, AWS also limits the number of VPC peering connection that one VPC can have, so 125. This means that eventually you are going to hit a snag. How do we untangle the mesh? AWS offers a service called a transit gateway. So the transit gateway ideally is the resource that you would use to interconnect all these VPCs. This means that you would only have to form a connection to the transit gateway, and then within the transit gateway, the route tables come into play, and you control how your traffic traverses your environment. An advantage of the transit gateway is you can also do site-to-site VPNs now with your premises or with other cloud environments, and all this is controlled from a central resource called the transit gateway. This goes a long way to alleviate the disaster of the huge mesh that we saw earlier when we do peer-to-peer connections between all our VPCs. So as I said, you would bring up a transit gateway and attach your connections to the transit gateway. When you do this, then you achieve full connectivity because now your VPCs are interconnected with each other through the transit gateway, making it less messy and more efficient. You can form your VPN connections to your transit gateway and manage them. And you can even have a direct connect. A direct connect is simply a layer 2 connection from the customer premises to AWS. Therefore, you don't go through the public internet using a site-to-site VPN. Another question comes to play. How do I pass traffic between my AWS resources? So an example is you've deployed your resources, say, in the London region, and you would like to interconnect these with other resources that you have in the Israel region. So would you send your data over the internet? Or is there a more efficient way of doing this? So without endpoints, then all your traffic has to pass through your NAT gateway, then the internet gateway, and then traverse to the internet. However, this is not efficient because if traffic is leaving this internet gateway to another VPC elsewhere or to another region, you incur data transfer charges. And it has been our observation as partners and as solution architects that a lot of clients incur huge data transfer charges because the environments are not properly architected. So, what would a proper architecture be? So when you use endpoints, then it means that all your traffic passes within the AWS network and never goes to the public internet. So when you use an interface endpoint, then it means that you have configured your traffic to flow between your resources within AWS without going to the public internet. And that goes a long way to be a properly architected environment and saves you cost together with securing your traffic. So you have your resources deployed in the cloud, everything is up, your transit gateway is up, but you have a need for the people who sit at the office within the data center to manage resources, or your servers work with each other. That is, the servers that sit on the cloud and the servers that are in AWS. One of the ways of connecting them then is use a site-to-site VPN. So AWS gives you the option of configuring a site-to-site VPN, and it is a redundant one, which means that you get two public IPs which you configure to your on-premises customer termination equipment. So that will be your router or your firewall. Because it is redundant, in the event that one of the public IPs goes down, or whenever AWS is maintaining that tunnel, you do not lose connectivity. Connectivity is assured through the redundant site-to-site tunnel. Some clients, however, have traffic that the site-to-site VPN would not sufficiently handle. Or sometimes clients have applications that require extremely low latencies that going through the site-to-site VPN, because this is tunneled over the internet, would not meet the quality of service that they require. Then comes Direct Connect. I mentioned earlier that Direct Connect gives you a layer 2 connection. So for those of you who are familiar with networking components, we have layer 1, which is the physical layer. We have layer 2, which is the data layer, and layer 3, which is the network or routing layer. So when you have a layer 2 connection, it means that you have a direct pipe connection to AWS. This goes a long way to improve the quality of service that you get through fast speeds and low latencies. Your capacity increases as well. To note, or important to note, is that this service, however, costs much more than the site-to-site VPN because of the quality of service that you get and the physical resources required to get it up. So that concludes networking. And to summarize networking, then, it is important to design your network as you deploy your resources. Sometimes you think that it is not a matter to put task to, but as the cloud environment grows, you realize that you have to make a lot of changes to accommodate the growing infrastructure. This then messes you up. So, to summarize the networking in AWS, then you need to keenly look at how your subnets are done. You need to consider connections that you will have with your on-prem, and you need to choose the right service to ensure that you give the best and the business focuses on delivering services rather than computing. So in this slide, then I have AWS Skill Builder, where you can go and train for free. By training for free, you gain vital resources or vital skills in the cloud environment, and you will happily become a cloud engineer or any other cloud role that would be suitable for you. I will promptly move on to the security presentation. Please let me know when you can see my screen. I believe my screen is visible. A confirmation on the chat, please. Anybody on the chat, please confirm that you can see my screen. Okay, I have reloaded it. Please confirm now.
Okay,
Great.
I can see your screen, but I
Super.
don't know what.
So Atom and Lola confirmed that they can see it now. Thank you, Atom and
Hello,
Lola.
Paddy, can you hear me?
Yes, I can hear you. Great. So we have deployed our resources within the cloud, and we have looked at ways of making sure we have a proper network setup. But now comes in the security conversation. I need to mention that security is a day zero task. So, what does a day zero task mean? It means that as you plan your cloud migration, or as you plan to deploy your resources in the cloud, security should be at the forefront of your deployment. First of all, AWS is compliant, or AWS meets compliance requirements globally for security needs. What this means is you can trust AWS to securely host your applications and infrastructure. So, to back this up, then on AWS Artifact, that is one of the services, you can easily go and download the compliance reports that the cloud environment meets in case you have or there are questions from your vendor to answer questions on compliance or concerns around compliance. Now, how does security work in the cloud? Security is a shared responsibility on the cloud or in the cloud. What this means is both you or me as a customer and AWS have our responsibilities when it comes to security. So, where is the line drawn? AWS is responsible for security of the cloud. Security of the cloud encompasses the physical infrastructure that they give you, their regions, their availability zones, the compute hardware, the storage, the database, and the networking components. It is their task to ensure that these are secure. Where do you then, as a customer, come in? The client or the customer is responsible for security in the cloud. And security in the cloud, then this means the operating systems that you deploy, how you configure traffic flow within your environment, which ports you allow traffic to go through, and who do you allow to access the cloud environment, and what can they do. So just to repeat that, AWS secures the cloud while you secure the data in your cloud and how it is accessed. So this is a deeper overview or a deeper view of where the responsibilities lie. So AWS handles physical and infrastructure, while the customer handles configurations, authorization, and the people who manage or who can access your data. So your data is as secure as you prescribe it to be. So then, what are the security services that AWS has to ensure that we are running in a safe way? Under identity, the services are listed and we will go through some of them. There's detective control, there's infrastructure security. We need to protect our data And finally, when incidents occur, then we need to be able to react or respond efficiently. We then start with identity and access management. So, what is IAM? IAM simply defines who can access the data, what do they have access to, that is the level of privilege, and when or how do they interact with this data. So there's authorization, and access. So as I said, IAM supports multiple options, including federation. So federation is where you as an organization are already running an identity provider. Call it Microsoft AD or Google Workspaces identities. You wouldn't need to come to the cloud and create individual users again. You would simply federate access. What federating access means is anytime a user is to be authenticated at AWS, AWS passes the request to your IDP, and when you're successfully verified, then you are allowed access into the resource you want to have. Next, then becomes detective control. So we are running, but are we always aware of what's happening on our environment? So, which tool does AWS offer us? We have AWS config. The cloud, as I mentioned, or on your cloud console, you have access to many regions. And if not properly controlled, then developers or users will spin up resources in the many regions. And trust me, it is hell looking for where these are when your costs are skyrocketing, but you don't know where these are coming from. So AWS Config is a managed service that gives you an audit of who did what where, so that in case you're trying to track an action by a user, you'd simply go to AWS config and check your history. It also notifies you of any resource configuration changes. Finally, you can go ahead to set rules of how resources are deployed so that you restrict what can be deployed or not. And this gives you a granular control of your cloud environment. So config gives you checks on who does what where. You can enforce rules to ensure that some of these conditions are met. That is, CloudTrail is enabled, your volumes are encrypted, resources are tagged, instances are backed up, multi-factor authentication is set up for your user accounts, there is proper logging within your resources. The next service in security is guard duty. And guard duty scans continuously for malicious behavior within your account and from your workloads. So guard duty continuously monitors and knows the normal behavior of how services are in your environment. When anything out of the norm occurs, then guard duty notifies you of the malice or the unusual activity, and you can take action or react to this. So it is an intelligent threat detection that scans your environment continuously, uses the logs to look at unusual behaviors, detects threats, and enables you to take action based on insights. Now, all these tools, Guard Duty, IAM, Inspector, and all the likes, sound like a handful. And it becomes a challenge sometimes to manage all of them at the same time. So all these tools are consolidated into a security hub. So the security hub is a dashboard that brings together all your logging and security tools and gives you a graphical view so that you have an easier time to analyze the security posture of your environment. There is also Trusted Advisor, and what Trusted Advisor does is it checks for performance, it checks for a properly secure environment. It checks if your environment is fault tolerant. And fault tolerant means that if a service goes down in a particular availability zone, then the users are not interrupted. They continue to enjoy service from a different availability zone. So, trusted advisor is your everyday personal assistant that notifies you or continuously scans your environment to ensure that you're properly set up. What then happens when an incident has occurred and you need to see what happened, where, and at what time? You get full logging features from CloudTrail as a service, and from these services, then you are easily able to track actions and what is happening within your resources. It's easy to integrate these log analysis features with other tools such as Splunk, Sumo Logic, and Alert Logic to enable you to do a proper analysis of your logs and identify any divergences from your normal operating procedures. You also need to track usage or user activity on your environment, and CloudTrail, in tandem with the other tools, continuously gives you logs and helps you to understand and keep track of these services. Now, CloudTrail gives you the logs. However, how do you monitor? How do you monitor CPU usage? How do you monitor memory usage? How do you ensure that you are prepared so that if an instance reaches 90% use of CPU and memory, you can quickly react to it? CloudWatch is the service that comes to play. So CloudWatch is a monitoring service that will continuously analyze and keep track of metrics. Metrics being CPU usage, network usage, memory usage, services that aren't enlisted. It checks on your backends, it checks on your database connections to your applications, it checks on the health of these databases, and all this is so that you can get in time actions and be able to have time to react to any outages that might occur if you do not take any actions. Finally, you have VPC flow logs, and VPC flow logs enable you to track or analyze network traffic. So, is there malicious traffic coming from a particular source? When you go to your VPC flow logs, then you are able to ingest and understand these types of metrics. Now we have secured our people, we have secured the environment. Earlier on in the networking presentation, I mentioned that we have the concept of subnets and availability zones. So, how do you segregate the resources? I mentioned that you configure security groups to secure your instances. You configure network access control lists at the network layer level to secure the subnet. When you want to have secure communication between on-site or on-prem and AWS, then you configure site-to-site VPNs or direct connect. Additionally, if you have multiple AWS accounts running, then you now might graduate to control tower and AWS organizations to manage your whole IT estate. Additionally, I mentioned that when you don't want your traffic flowing between AWS resources to go through the internet, then you use VPC endpoints. So endpoints enable secure traffic within AWS. Traffic does not egress or get out to the internet, then back into another AWS region or particular resource. As we conclude, there's AWS Shield. So lately, we have been observing DDoS attacks to various resources and governments, and these affect service delivery to clients and to customers. When you deploy or when an organization deploys their resources to the cloud, There's always malicious intent by threat actors to bring down these services, and a DDoS attack is one of the easiest places to start from. What that does is it interrupts the delivery of services to the customers. Having recognized this as a threat, AWS provides a service called AWS Shield. So, Shield is your built in protection, DDoS protection for everybody. However, with Shield Standard, you only get a standard DDoS protection for everyone. And who wants what everyone can get? As an organization, when you feel that the standard tier is not enough for you and you need further insights and visibility into the threat actors targeting your environment, then you pick the AWS Shield Advanced. AWS Shield Advanced then offers you all the resources or all the services highlighted in yellow. So you have enhanced protection. You can get diagnostics onto who is trying to attack what are they doing. You get 24/7 access to a DDoS response team so that if you're being attacked, you have a team of engineers who will help you alleviate or respond to this. You have a global threat environment dashboard so you can see from which regions are these attacks likely to happen from, and am I protecting my resources from access within those regions. So it is important to take into consideration the business needs, the risks, and the cost of what you want to incur to protect the services you offer. Amazon Inspector is another service, and Amazon Inspector analyzes your practices within your environment. So it integrates into APIs, and what it does is it validates configurations and checks if your DevOps practices are done in a recommended way. So, for one, it checks your machine images to make sure that these are secure and certified images that you're using. It checks for software changes, zero-day vulnerabilities are continuously assessed, and it ensures that your software development lifecycle is secured or deployed in a secure manner. So how do you use it? You configure an assessment and you run it. From this, you get vulnerability reports that give you the affected resource and a recommendation that you can take to remediate where you are lacking. So AWS allows you as a user to penetration test your resources. So because they have assured you that they have compliance and their environment is secure, and as a user you have done your best to make sure you meet your share of of the shared responsibility model, then you can go ahead and penetration test your environment is to make sure that as a user you are happy and satisfied that your demands are met in a security posture. Finally, you have protected your environment, your software lifecycle is properly set up, and everything. How is your data being sent, and how is your data secured when it is sitting within your storage? And there comes in encryption. So AWS offers you encryption at rest and encryption in transit. So encryption at rest is your databases, your disks, your objects in your S3 buckets, and your file systems in your EFS systems. So these are encrypted at rest depending on which encryption tier you choose. When data is being sent over the internet, then we offer you encryption in traffic through SSL and TLS protocols, the VPN and IPsec tunnels that you form, and SSH secure shell into and out of your instances as you log into them to configure your services. Additionally, there's a certificate manager that you're issued for SSL and TLS to help you configure your load balancing and CloudFront. So this secures the web access or the web interface that you expose to your customers. So data at rest, how do we handle data at rest? Data at rest is managed through AWS Cloud Hardware Security Module, which ensures that physically your data is encrypted and secure. The key management service handles certificate dishing for your data that sits within AWS. So the key management service simplifies rotation of keys, creation of keys. It integrates with the services such as S3. It integrates into CloudTrail to give you proper auditable logs into how your keys are being operated into the cloud environment. And it is a service that is globally available. Now, your environment was secure, you're positive that you are set up properly, but one salient night, an incident occurs. Customers are raising tickets that they cannot access your environment. The DevOps team is helter skelter running around trying to fix things. So how does AWS come in to help you to respond to incidences in the event of attacks? So when attacks occur, Guard Duty, as I mentioned earlier, will detect these attacks from your logs on CloudWatch. Then you can get reports what has been affected, where, and you can put in automated controls using Lambda to react or to remediate the attack and to ensure that your services resume and are running as required. At the beginning of this presentation, I mentioned that security is a day zero job. And this means that at the moment you decide that you are going to the cloud, then you need to start taking into consideration security practices that you will use within your cloud environment. So AWS is designed for security. It is constantly monitored through the tools that I've mentioned. There is high automation so that the day-to-day tasks are abstracted from the users. Services are highly available through availability zones and redundancies through them. And finally, AWS enjoys compliance and is highly accredited by global or through global standards. That brings me to the end of my AWS networking and security presentation. I am happy to answer questions from anyone on the chat. Back to you, El.
All right, thank you so much, Paddy. Can you hear me?
Yes, I can hear you.
Can you hear me? All right.
Yes, yes.
Please indicate if you can hear me. All right. Okay, please, if you have questions, please drop it on the comment section so Paddy can take them. So please, either you are joining via YouTube or via LinkedIn or Twitch, please drop your questions. I think we have a couple of persons here joining from various platforms. Please drop your questions. And also, I'm going to quickly share his LinkedIn handle so you can connect with him via LinkedIn. And if you have personal questions or you want to reach out to him, you can send him a connection request. And please do well to drop your questions so he can take them. Yes. Okay. So we're waiting for that. And also, the attendance form is being passed on the comment section also. So please do well to fill the attendance form. All right. I'm not seeing any questions. Okay. Let me just go through the chats. Let me just go to the chat. Please, if you have your questions, please drop them now so your instructor can attend to them.
Key Fox has a question about.
Okay, so there's someone, Air Fox. Okay, so yeah, so let me display this on the screen. Okay, so I don't know if you can see what Paddy. Can you hear me?
Yeah, I can hear
Okay,
you.
so there's Fox Wonko has a question as regards penetration test. So I think
So
that is
what
being
is the
displayed on the
question?
screen.
What is the question?
Okay, he said, "Thank you, sir. I have a question about penetration tests." Okay, so
So
Kefox,
yeah,
if you can
he
hear me,
hasn't
please,
asked.
you
Yeah.
can, yeah, you can go on. Thank you.
If AWS created environment for such, how can we be sure it will go wrong? If AWS created the environment for such, how can we be sure it will go wrong? So you cannot be sure it will go wrong for one. And as I mentioned, security is a shared responsibility. What AWS or why AWS, and if you follow the link that I presented, then you can read about the penetration test uh, procedure that they give you or what they allow you to do. Is AWS is confident that their resources or how they posture their services in the cloud is secure, provided you adhere to your responsibilities as outlined in the shared responsibility model. Therefore, I wouldn't expect you to leave open a port and then try to penetration test your environment. That you are definitely going to get in. So provided you have adhered to your responsibilities within the shared responsibility model and your deployment also aligns to the well architected framework and the practices that they have in that, then you are welcome to try and find vulnerabilities within these deployments and services and report them to AWS. So there's a practice or there's a set of rules that govern penetration testing, and you need to read that document as you engage in that activity. Are clients allowed to use their own means for penetration test? As I said, please read the document and ensure that you tick all the checkboxes before you embark so that it is ethical hacking and not anything that will be interpreted as criminal. Any other questions?
Hello, Paddy, can you hear me? Okay, I
I
think
can
it's
hear
breaking
you.
from my end. Can you hear me?
Yes, I can.
Okay, if you can hear me. Okay, so there's another question from Oliver. I don't know if you can see it from here. So he said you talked about direct connect being costly. What are some of the best practices to optimize costs if a client wants to migrate to AWS cloud? I don't know if you get that.
Yeah, I can see the question. So I talked about direct connect being costly. So what are some of the best practices to optimize cost if a client wants to migrate to AWS cloud? So first, as you're considering your cloud migration, AWS gives you tools for you to estimate what your cloud spend will be. And this tool is called the AWS cost calculator. So I will paste that here. So through AWS cost calculator, then you are able to get an estimate of what your cloud spend will be for budgeting purposes. Additionally, AWS offers you different purchase models. So, for one, you can use the services on demand. And on demand means you pay as you go every month. When you show commitment or when you're sure of the service you're consuming and the duration of consumption of that service, then you can move into savings plans or reserved instances. And these ones enjoy discounts of up to 40% on the services. So if you are running a virtual machine, the EC2 instance, once you've run it for 2 months and you've observed your spend, you can easily reserve or purchase a savings plan for that instance. And this lowers your spend. Also, you need to set budgets on your cloud environment, and these budgets need to be monitored. So AWS again allows you to set budgets and get notifications or even do additional configurations on what happens when these thresholds are met. Therefore, you will continuously receive alerts according to the budgets that you set. And there's always a new service that is churned out to make you run in a more efficient manner. Therefore, you need to keep a lookout for AWS updates onto what is running. If you're running an EC2 instance and there's a managed service that will cost cheaper, then happily transit into that and lower your cost. So for one, you are able to calculate the cost of what your services will be. Two, once you're sure of your spend or how or which resources or you have deployed, you can purchase reservation plans or savings plans, which give you up to 40% plus discounts. And three, always continue optimizing your cloud environment so that you take advantage of the best technology that offers you the best service and ensure that budgets are set so that you are notified when these thresholds are met or breached. Ella, I think we don't have any more questions.
Oh, hi, Paddy. Can you hear me?
Yeah, I can hear you, Maka.
All right. So, thank you so much for being on this session. I'm not sure there are any questions left. You have answered every question here. Okay. Yeah, you have answered every question here. So, thank you so much. If there are any more questions, we'll get it across to you. And like Ella said, we'll drop your LinkedIn handle here so the students can follow you and send you messages. That's if you don't mind.
Yeah, I'll
Can you hear
happily
me?
answer any questions. I will happily answer any questions that come along.
All right, no problem. Okay, with that being said, thank you for calling. Have a lovely day ahead.
It's been a pleasure. Thank you as well.
All right. Bye, everyone.
Bye.
All right. Bye, Patty.